Hello, and welcome to Behind the Science, where we ask challenging questions directly to scientists who are trying to solve today's toughest problems. And I'm your host, Jennifer Fournier. Today, I am in my lab exploring this new gadget I got for the kitchen. I love to cook and to try new tools to help make cooking easier. And in the end, the food really does taste much better. Science is a lot like cooking. With the right tools, you can make a difference in quality. I have a dilemma though. I am super comfortable in the kitchen, but not so much in an LC-MS lab. Running optical detectors? No problem. I sure would love the benefit of mass spectrometry though. But those detectors look highly complicated. I wouldn't know the first place to start. I do dream of that added confidence of having a mass assigned to every peak though. So in this episode of Behind the Science, let's take a field trip to the LC-MS lab to tackle my fear of serial detection. Hi, Steve. Sorry to startle you. But I think you're just the person that I need to find. I need you to help me get over my fear of serial detection. It looks really complicated and it's intimidating, but I really want to assign a mass to all of my chromatographic peaks. Do you think you can help me?
Well, I think I can, Jen. You're in luck. I've been setting up a system to run today.
Great.
I'm actually going to be setting up to run some peptide mapping and using the QDA detector, our little mass spectrometer, to help me develop my map. But the same principles are going to apply to you as you do your glycan analysis because you're using the RapidFluoresMS label, and it will give you a signal that will allow you to see it with the same detector.
Great. Could you show me a little more?
System.
Oh,
Sure.
perfect.
So this is the system as it stands. This is our UPLC system, H-Class Bio. This is the pump. This is our injector. And we're going over to our TUV detector. This is just UV absorbance detector. And then we drop that in our serial detection into our mass spectrometer.
But I'll be using a fluorescence detector, right?
Yeah, you will, because
Okay.
you're doing the fluorescence analysis for the glycans.
Right. And I can just put that right there?
Absolutely.
Fabulous. So, can I
Whoa,
see?
careful, Jen. No, I'm just kidding.
Okay.
That's nothing to really hurt you there. It's really set up to be used by a novice mass spectrometrist. There's really no special skills. It works with Empower software. You can kind of tie in everything quite nicely. And it's basically this small unit is our mass detector or mass analyzer. And then we have an extra pump down here to give us some more sensitivity.
Great. That doesn't look too bad.
No, it's pretty easy. Let me show you some of the details. Here's a nice visualization of what we're looking at with this instrument, Jen. It's a nice, simple quadrupole design, but it's really much more than that. It also includes automated resolution and calibration, as well as pre-optimized tuning, as well as really simple user-capable maintenance. So even a novice user like you, who's really afraid of the thing, can get in there and really use it and get a lot of information out of it.
That's great. Easy, simple, and powerful.
I think you'll like it.
Steve, I'm feeling a little bit better about serial detection. It's not so intimidating now, but I'm still a little unsure if I could do this.
I have a lot of faith in you, Jen. And I'll tell you, there's a lot of good reasons you want to get over this and really use this to your advantage. One is when I'm developing peptide maps, or if you're developing your glycan separation, you'll be able to use this QDA to track where your peaks are going and really optimize your separation. Another good reason is when you're doing routine analysis. If you have peaks that are co-eluting, or if a new species comes up underneath one of your already identified species, you'll at least have a handle on what's going on there. But there's a third really good reason, and let me show you that.
Wow.
Another characteristic for this detector that can really take advantage of, Jen, is that if you really need to have high throughput analysis on the LC part of your separation, you can take your method and kind of squeeze it down, and that's shown here where we've gone from a 55-minute method to a 10-minute method. Of course, now we have some coelutions going on here, so what we're going to do is use the QDA to basically monitor our important peaks and report back what we're getting for it in terms of the relative abundance of those peaks.
What a great time savings.
Sure is.
Steve, you've given me a lot to think about. I think I might be able to handle this serial detection and adding the QDA to my stack. But you know what? You've opened up my other fear, and that's data analysis and informatics.
Oh, Jen, I don't have time for that today.
Serial detection really isn't that bad, especially if one could have a small mass detector that is also friendly and easy to use. And what a perk! I never thought about being able to shave off some analytical runtime as well. That is a huge advantage. Mass detection can be approachable for any user. LCMS empowers every scientist to have as much information as possible at their fingertips to make those important decisions. It just goes to show, if you have all the tools, you can make a 5-star dessert, rich and so delicious. Check out the links below to read more about serial detection and how some of these methods were developed. And join us next time as we go behind the science to answer the last question of the glycan series. Does data analysis for glycans need to be so hard?